Hi everyone! In this video, I will give an overview of the Java collection framework and talk about some best practices related to using generics and collections. The Java collection framework provides a library for managing collections of items. You will learn about the interfaces and classes in this library, such as lists, sets, maps, stacks, and queues. You will also see some best practices using these data structures, such as always specifying the type of your collections, preferring lists to arrays, and programming to interface, not implementation. The Java collection framework consists of three components: interfaces, classes that implement the interfaces, and algorithms for processing collections. Let's take a look at the standard collection that you've been using in your programs, lists. A list is a group of items where each item has an index indicating its position. It's similar to an array, except that you don't have to manage its size yourself. You can perform several operations on a list, including adding, removing, retrieving, and searching an item. List is an interface in the Java collection framework. Recall that an interface specifies what an object can do without worrying about its implementation details. It's the responsibility of a concrete class supporting this interface to implement the behaviors. Classes that implement the list interface include array list and linked list. Algorithms in the Java collection framework are implemented in the utility class collections, which allow us to sort, shuffle, and search items on a list. One of the best practices using these collections is to always specify their type. When you create a list, a set, or other groups, always state its data type. What kind of a list do you want to declare? Is it a list of string, a list of integer, or something else? The raw types are supported for backward compatibility with code written before Java 5, where generics were introduced. Since Java 5, we can parameterize a collection object with a specific type, such as creating an array list of string. Java is strongly typed language, and we should use this feature to help us catch mistakes early. Notice how I use an interface to declare a variable myList and call a constructor of a concrete class to create the object. List is an interface. ArrayList is a concrete class implementing this interface. The diamond operator should be included to get the benefits of type checking at compile time. Another recommendation is to prefer lists to arrays. Once you learn about lists, there are no compelling reasons to use arrays in your programs. Using a list is convenient, as it can grow automatically if necessary, so that you don't have to keep track of its size and manage it programmatically. Another benefit is that a list checks its type at compile time, while an array enforces its type at runtime. We know that we shouldn't try to store a string into a long container. However, the code snippets show that broken code that uses an array fails at runtime rather than at compile time. As a programmer, we want to catch programming mistakes as early as possible. Another best practice I want to discuss is program to interface, not implementation. We can make our code more flexible by using interface to declare variables, fields, parameters, and return type. For example, the getAverage method should take a list of students rather than an array list of students. It shouldn't matter whether the given list is an array list or a linked list. As long as it's a list of students, the method should be able to calculate and return the student's average. By using interfaces, our code can work with various classes that implement the interfaces. If necessary, we can also change the concrete type we use with little modification. Besides lists, there are several other collections in the Java collection framework, such as set, map, queue, and DAG along with concrete classes that implement them. A set is a collection of unique items. Items in a set don't have a specific position or index. We can check whether an element is in a set efficiently. Concrete classes that support the set interface include hasSet, treeSet, and link_hasSet. A map is called dictionary in Python. It's a collection of key-value pairs. For example, we can map students' IDs onto student names. Student IDs serve as the key, and student names are the values in this data structure. Keys must be unique and are used to retrieve values. When we need a dictionary, we can use hashmap, treemap, or link_hashmap. A stack supports the LIFO or last in, first out abstraction. The Java collection frameworks recommends using the double-ended queue or the DAG interface if you need a stack. Array DAG and linked lists are examples of concrete classes that implement this interface. Technically, a DAG is not a stack, but we can limit its behavior to behave like a stack. The table shows a comparison between stack methods and DAG methods. The Java Collections Framework supports a queue, a collection that typically orders the elements in a FIFO or first in, first out manner. Queue is the interface name, and it's implemented by linked list and priority queue class, among others. A priority queue arranges its items based on a given comparator or the item's natural ordering. To summarize, the Java Collection Framework consists of three components: interfaces, implementations, and algorithms. The interfaces specify the operations or behaviors that must be supported by collections. The implementations refer to concrete classes that implement these interfaces. The last component, algorithms, provides methods that can process groups of items, such as sorting, searching, and shuffling things. These methods are available in the utility class collections. Some best practices related to the use of collections include not using raw types while declaring a collection object, preferring lists to arrays, and programming to interfaces. These guidelines can help us develop robust and flexible programs.